So, what if I told you that mathematics isn't just a subject, it's a language? Yeah, a language that literally describes the very fabric of the universe. And today, we're going to learn how to read it.
Just imagine for a moment, everything around you, from the way planets orbit the sun to the little buzz your phone makes, is all written in a kind of secret code. A code that explains how the world actually works. And the really incredible part, you can learn to read it. Because that code, well, that code is mathematics.
And that's the core idea we're diving into. Math isn't just about finding X in a textbook. It's this precise and, universal language for describing all the patterns and relationships that govern our reality. And just like any language, once you get the basics down, you can start telling some truly incredible stories.
So, where do we start? Well, every language has a foundation, right? A grammar that holds it all together. For the language of the universe, that grammar is algebra. It gives us the fundamental rules that make everything else possible.
If math is a language, then a simple little thing like x plus 5 is our first phrase. It's a basic mix of constants, the numbers that don't change, and variables, which can stand in for almost anything. We're not forming full sentences just yet, but these are our essential building blocks.
In this language has very specific rules. Take the distributive property. This isn't just some random procedure to memorize. It's a core rule of grammar that makes sure the language is logical and consistent. It tells us exactly how the different parts of an expression interact, so the meaning is always crystal clear.
I mean, think about it. In English, dog bites man is a totally different story from man bites dog. The order, the syntax, it matters. And the same is true in math. The order of operations, that's our syntax. It's a universal agreement that makes sure a mathematical sentence can only have one meaning. Without it, you just have chaos.
And as we start building more complex ideas, we need little tricks to keep our grammar straight. The FOIL method, for instance, isn't some brand new rule. It's just a handy guide for applying that distributive property correctly. It helps us combine our simple phrases into more complex, but still perfectly structured statements.
Okay, so once you've got the grammar down, you can do something really amazing. You can start telling stories. In the language of math, our most powerful stories are called functions. They take all those rules of algebra and use them to describe the real-world relationships that shape everything around us.
At its heart, a function is basically a story of cause and effect. It's a simple but incredibly powerful rule. For every single input you give it, you get exactly one predictable output back. This simple idea lets us model, predict, and actually understand how one thing changes when something else does.
The simplest story a function can tell is one of steady, constant change. We call this a linear function. Its graph is just a perfect straight line, and it tells the tale of anything that grows or shrinks at a steady pace. Like a car cruising down the highway at a constant speed. Predictable, simple. But let's be real, life is rarely a straight line. So what about stories that involve acceleration? For that, we use quadratic functions. Their graphs, these beautiful curves called parabolas, perfectly capture the story of something speeding up or slowing down. Just think of the graceful arc of a ball tossed into the air as gravity pulls it back down. And then there's the most dramatic story of them all. Exponential growth. This graph tells a seriously stunning story. It starts out slow, almost flat, and then it just explodes upward with breathtaking speed. This is the story of compounding, of a viral video, a booming investment, or even a chain reaction.
Now, functions tell these perfect, clean, idealized stories. But the real world, it's messy. It's unpredictable. To read that story, we need a whole different part of the language, statistics. This is how we find the meaning hidden in all the chaos.
So what happens when the story isn't some nice, clean curve? I mean, look here. We've got student enrollment data. It's not a straight line. It's not a smooth parabola. It's just data. So how do we find the story that's hiding inside all of that real-world messiness?
To handle all that uncertainty, our language has a special tool, probability. It's the vocabulary we use to measure how likely something is, to put a number on randomness, and to make smart predictions even when we don't have all the answers. It's how we find the signal in all the noise. And we've got these really powerful tools to help us see those hidden patterns. A histogram, like this one, takes a jumbled up data set and organizes it visually. It shows you the shape of the data, its distribution. And suddenly, what looked like just a bunch of random noise starts to tell a story.
So, we have the grammar of algebra, the stories of functions, and the tools of statistics to interpret the messy stuff. We've basically learned how to read. Now let's see how this abstract language creates real, tangible solutions out there in the world.
Okay, check this out. It's a graph showing the relationship between how often crickets chirp and what the air temperature is. At first glance, it's just a bunch of scattered data points, but do you see the story starting to emerge? It's not perfect, but there is a clear, powerful trend there. It's that story of steady change we saw earlier.
And by applying the language of functions, we can actually model that trend with a simple line. And just like that, we've translated the sound of a cricket into a pretty reliable thermometer. We read a tiny piece of the universe's code and turned it into something useful. That is the power of this language.
From the basic grammar of algebra to the epic stories written in the stars, mathematics really is the language of reality. It is all around you, all the time, just waiting to be read. So the only question left is, what story will you choose to